In this lesson, we are going to be comparing different types of functions. So we have 4 types of functions here we're going to talk about: linear, exponential, quadratic, and absolute value. We have talked about linear, exponential, and quadratics before, but absolute value, this will be new for us. So the first one, linear. What does a graph of linear look like? Well, it's going to be a straight line. It can be a diagonal line. It can be a line that goes up and down. It can be a line that goes across. What are some examples of equations for linear? Well, you have something that's in slope-intercept form. So y equals 4x plus 7. Or you can have something in standard form. 2x plus 3y equals 6. Or you can have a vertical line. X equals 4. And lastly, you could have a horizontal line, which is y equals -2. Exponential. What does an exponential graph look like? Well, it looks like a curved graph. Examples of exponential: y equals 2 times 10 raised to the x, and y equals 1/3 raised to the x. One thing about linear, we should make sure that everybody knows, I forgot to add in, linear, the exponent is 1. For exponential, the exponent is the letter x. Third one, quadratic. A quadratic looks like a U shape. And we have 3 different forms for a quadratic. You can have something like y equals x squared plus 3x minus 5. Y equals parentheses x minus 3 quantity squared plus 7. Y equals parentheses x minus 1, x minus 5. Okay, when you look at this one, the exponent is 2. Now, what might be tricky is this last one here, because the people on this last one, they'll say, oh no, there's no powers here. But if I was to multiply x times x, well, x times x is x squared. So even though there is no power there, if I was to still multiply this out with the box, I would have a power of 2. The new one, absolute value. Well, absolute value will look like a V shape. And to be absolute value, the equation has to have the absolute value bars in it. So here's my bar, and then x minus 3. Here's my bar for absolute value, plus 7. All right, example number 1, all of these in example number 1, you just get to name the function. So is it linear, exponential, quadratic, absolute value? And then once you have named it, tell me what the shape of the graph would look like. So on the first one, I'm going to go through and I'm going to look at my powers. And my power is to the first. And anything with a power of 1 for x is linear. And it looks like a straight line. And I'm going to abbreviate straight with ST. B. Well, when I look at B, I see absolute value bars. Here's my absolute value bars. So absolute, which I'm going to abbreviate, value, which is a V-shaped graph. C. On C, I see a power of 2, and a power of 2 makes it a quadratic, which I'm going to abbreviate. And quadratics are U-shaped. On D, I notice, oh, the power is the letter X. If the power is the letter X, then that means it's exponential, which I'm going to abbreviate. And exponential is a curved graph. So now you pause the video and try the next four yourself. Okay, so hopefully you've checked those and you're okay. So moving on to our next example. Instead of identifying the type from an equation, now let's look at a picture. So look at these four pictures and write down, do you think it's linear, quadratic, absolute value, or exponential? Straight line is linear. V-shape is absolute value. U-shape is quadratic. And a curved line graph here is exponential. Okay, now we get to do some evaluating. And evaluating is giving us an answer. And then just want to make sure that everybody is aware of this. Instead of starting with y equals, do you notice that it starts with f parentheses x? Well, f of x is function notation. Oh, my pen's not working. Hold on. Function notation. And y is equation notation. But you need to know f of x and the letter y are the same thing. It's just function and equation, same thing, just different ways to call it. So don't let f of x confuse you. So over here, off to the side, it says f of 2. So instead of f of x, it says f of 2. So that means x equals 2. So when I look over on my functions, I want to go on the right side of the equal sign, and wherever I see an x, I'm going to plug in a 2. So 3 times 2 minus 8. So that's 6 minus 8, which is negative 2. Going across. Plug in 2 for each x. This one has 2 x's in the function, so make sure you plug 2 in for each one. And then pull out your calculator and type it in exactly how it looks with parentheses and all. And you should come up with 15. Over here, 3 parentheses 1/2 raised to the second power. So make sure when you type this one in that for the power of 2, you hit our exponent key, roof of the house key, and you should come up with 0.75. And then the last one, absolute value bars. Okay, let's take a step back and see if everybody can remember absolute value. Okay, and down here at the bottom, absolute value is the distance on a number line, a given number is from 0. So on this example, I got absolute value of 2 plus 7 and then plus 5 off to the side. Unfortunately, your calculators do not have absolute value bars, so we kind of have to do this one mentally. So let's first go inside the absolute value and get it down to a single number. So 2 plus 7 is absolute value of 9. Well, absolute value of 9. How many spaces is it from 0 to 9 on the number line? And you should say, oh, well, it is 9. And 9 plus 5 gives me 14. Okay, let's try another one together. This time, f of -4. So we're saying x is -4. So 3 times -4 minus 8. And if you type that into your calculator, you should get -20. And then 2 times -4 squared plus 4 times -4 minus 1. Type that in exactly how it looks, and you will get 15. 3 times 1/2 raised to the -4th power. And if you type that in exactly how it looks, you will get 48. Absolute value of -4 plus 7 plus 5. Inside the absolute value, what's -4 plus 7? Well, that's +3. And the absolute value of 3 is 3. Because what's the distance from 3 to 0 on a number line? It's 3 spaces. So 3 plus 5 is 8. All right, you try the last row by yourself. Okay. Moving on. All right. On the back side of our notes, we are going to be looking at different tables. And our job is to look at a table and decide, is that table either linear, exponential, or quadratic? So we only have 3 choices this time. Okay. We don't have to worry about absolute value. We're just doing linear, exponential, and quadratic. We have done these all in separate units, but now we're just going, well, except for quadratics. Sorry, let me back the train up there. We did linear and exponentials, but we haven't done quadratics until right now. Linear. To be linear, you're looking at the y numbers or the f of x numbers, because remember, f of x, y, same thing. And the pattern must be adding or subtracting. And then if I ask you to write an equation or function, it could say f of x or y, whichever one we want. And then most of us hopefully remember slope-intercept form, mx plus b. M is your slope, which your slope is your pattern number. So going up 7 each time or going down 3 each time. And b is your y-intercept. Exponential. To be exponential, you look at the y or the f of x number, and the pattern is multiplying or dividing. Now, what if you don't see a multiplying or dividing pattern that jumps right out at you? What you could do is you can take the second y and divide it by the first y. Take the third y, divide it by the second y. Fourth y divided by the third y. Or however many numbers are on the table. But it's always the one past it divided by the one in front of it. And if they all reduce down to the exact same thing, then that makes it exponential. Okay, our equation or function looks like a times b raised to the x power. B is your pattern number, but there's a catch. When I say it's your pattern number, we can only write the pattern number for multiplication because it says a times b. It doesn't say a divided by b. So we can only write it 4 times. And then once again, if you're not sure, right here, I wrote down again y2 over y1. And a is the y-intercept. Okay, quadratic. To be a quadratic, the pattern of the y or f of x numbers is the second difference all the way through would be the same. And then we're going to only be working with the most basic quadratics, and the most basic quadratics will look like ax to the power of 2. And a is going to be half of your second difference pattern number. So when I say pattern number, I mean the second difference number. So it'd be half of that. So let's go give some a whirl here. So first thing, look at the f of x or the y numbers. Okay. And I'm just going to go with, let's check linear first. So let's find the difference. How do I get from 12 to 3? So to get from 12 to 3, I have to go backwards. And if I'm going backwards, that means I'm subtracting 9. Everybody okay? 3 minus 12 is 9. Negative 9, sorry. And then how do I get from 3 to 0? Well, to get 3 to 0, I'm also going, whoops, sorry, my screen switched. Let me see if I can get it to switch back. There we go. You're also going backwards. Oh, no, I just made it smaller. All kinds of things going on. Hold on, kids. Sorry about that. Anyway, we're going backwards. So the spaces there is negative 3. Now 0 to 3, we're going up because we're getting bigger. So this time we're going up 3 spaces. And 3 to 12 is getting bigger. So that's up 9 spaces. To be linear, those 4 numbers right there would have to be identical. And our 4 numbers are not identical. So linear is off the table. Okay, if I was going to check exponential, for exponential, I would go ahead and say, all right, let's do second y over first y. So 3 over 12. Then let's do third y over second y, which would be 0 over 3. And I could keep going except for right here. Is 3 over 12 the same thing? If it reduces down, will it be the same thing as 0 over 3? No, it will not, because 3 over 12 reduces to 1/4, and 0 over 3 reduces to 0, and these are not the same number, so exponential is off the table. Now, quadratic says, go ahead and tell me the second difference. We did the first difference already. We got -9, -3, +3, +9. That's my first difference. So let's do second difference. Okay, I want to go from -9 to -3. So I'm going upwards 6 spaces. I want to go from -3 to +3. That's up 6 spaces. 3 to 9 is up 6 spaces. And then ding, 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 we have a winner. Does everybody notice my second difference is 6 all the way through? So that makes this one quadratic. And for quadratic, remember we're looking at y equals a x squared, or f of x. I don't care which one you use. And we said a was half of the second difference. So my second difference number is 6. Half of 6 is 3. So boom, there's my type. Boom, there's my equation. Okay, let's go to the next one, straight across. All right, I'm just going to start with linear again. -2 to +1. Well, that's up 3. 1 to 4, up 3. 4 to 7, up 3. 7 to 10, up 3. Well, all of those numbers are the same. So if my first difference is all the same, that makes it linear. And remember, linear looks like y equals mx plus b. M is my pattern number, so that is +3. B is my y-intercept. And remember, to be a y-intercept, you're looking for 0 on the chart. So underneath 0 is 4. So my equation is y equals 3x plus 4. Boom. Okay, let's go to the next one. Okay, I'm going to try linear again. So here I'm going down 4, down 2. Well, right there I can stop and say, well, it's not linear because those numbers aren't the same. Nope. Throw that out the picture. All right. So then let's say we want to try exponential next. Right, to get 8 to 4, 4 to 2, 2 to 1, 1 to a half, you might have a light bulb go off and say, ding, 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 ding. What do I notice? I notice that the pattern is dividing by 2. But if that doesn't pop out at you, then remember, do second y over first y, third y over second y, fourth y over third y, fifth y over fourth y. 4 over 8 is 1/2. 2 over 4 is 1/2. 1/2 is 1/2. 0.5 over 1 is 1/2. And then I'd say, oh, look here. They are all the same. And if they're all the same, that makes it exponential. And remember, the equation looks like y equals ab to the x. B is our pattern number, but remember we said we couldn't write the pattern number for division. Okay, we had to write the pattern number for multiplication. So multiplication would be the y2 over y1, so that would be 1/2. A is our y-intercept again, so find 0 on my table, and below that is 2. So y equals 2, parentheses, 1/2 raised to the x power. Boom. Okay, last one. Rocking and rolling here. For this one, I'm going to try linear. So I'm going up 0.5, going up 1.5. Well, right there, I could stop and say, oh, those aren't the same, so it's not linear. So exponential. 0.5 over 0. Well, 0.5 over 0 is not possible. If I try that on my calculator, it'll say error. So that tells me it is not exponential. So boom. So let's go check my second difference. So 0.5 to 1.5 is going up 1. Here we're going up 1. And here we're going up 1. So my second difference is the same all the way through. So that makes it a quadratic. And remember, quadratic is y equals ax squared. And a is half of our second difference number. So our second difference number is 1. And half of 1 is 1/2. So y equals 1/2 x squared for my equation. Boom. All right. Now it says, ooh, we get to match these. We already wrote our equations, and now we get to match them up. So let's look back at our answer for A. A was 3x to the second power. So where do I see 3x to the second power? And hopefully everybody says, oh, I see that on number 4. So number 4 is table A. Okay, linear. We wrote 3x plus 4. So where do I see 3x plus 4? And hopefully everybody says, oh, that's number 5. Exponential was 2 times 1/2 to the x. That is choice C. And the last one was 1/2 x squared. That is choice D. So we did not use not applicable on number 1, not applicable on number 2, not applicable on number 3, and not applicable on number 4. And we're done.